The idea, the statement here is that the perception of mathematical truth cannot be reduced to a set of mechanical rules. And this comes from a famous theorem due to Gödel, and Turing was certainly very familiar with this. It featured very much in his 1936 paper, the original one, because he was very much concerned with things that computers couldn't do, if you like. That was part of what he was trying to do. And so as to say what you couldn't do by a mechanical procedure, he had to define what he meant by a mechanical procedure and then show that there were certain things that you can't do with a mechanical procedure. Well, I'm going to phrase Gödel's theorem in a way which it's not normally phrased, but it is a perfectly correct deduction from his theorem. Tells us that for any mathematical theorem, and that's the kind of thing I'm talking about here with natural numbers and so on, it tells us for any set of mechanical theorem-proving rules, and when I say mechanical theorem-proving rules, I mean you have a set of procedures which can be checked by a computer. That's the crucial point. If you follow these rules and you come to a conclusion that it proves some mathematical statement of the kind we're talking about, then that alleged proof can be checked by a computer. So that's the kind of rules we're talking about. Then what you can construct is a particular mathematical statement, which Gödel shows you how to do, and I'm calling that G of R, which if we trust the rules, if we believe in the validity of the rules, that is to say, if we believe that anything we derive using the rules must be true, if you trust the rules, then you must also believe that this particular statement, G of R, is true. Yet, it cannot be proved using the rules. Now, that's a very striking, remarkable thing, because what it's telling us is that whatever these rules are, if they're rules whose consequences we believe in, then that belief or that trust extends beyond the rules themselves. And you have to know that the rules are trustworthy, and that belief that they're trustworthy enables you to extend beyond the rules, so that this particular statement, G of R, cannot be proved using the rules of R, but the way in which it's constructed tells you that must nevertheless believe it's true. See, people usually state Gödel's theorem in a rather negative way. They say there are certain things you can't prove. But what they mean is you can't prove using a very specific set of rules. But if you trust those rules, then you can see that statement is true. And this is a very striking thing about the Gödel statement. And clearly Turing was very much aware of this, and that